So I'm going to talk to you now, as Ethan said, about work by Ethan and also by me on multitask problems and accountability in an electoral context. So if we want to think about executive authority, we need to think typically about lots and lots of jobs, right? Not just the one job that's common in a lot of models of political agency and accountability, but instead many tasks. So for example, a local government might have to be in charge of police and also in charge of schools. And then a question arises, do you want those two jobs to be done by one official who's going to stand for election as a unit, or by two officials with one election for each of them? That's a sort of a live issue right now locally. You also see a lot of heterogeneity in terms of how that's resolved. So at the federal level, we have one election for executive, but at the state level, many states have lots of elections for executives. You can elect the Attorney General and the Secretary of State and the Treasurer and so on. So we're going to make a first step at one approach to understanding the electoral side of that institutional design question. So we're going to ignore all sorts of interesting questions about delegation inside the executive and just think about the executive's relationship to voters. And we're going to say, do you want to combine the task or not? And the answer is going to turn out to depend on what the division does to two things. So there's accountability. This is how efforts are going to be shaped by re-election. And there's going to be a trade-off there, which is basically if you separate the two offices, you're going to get efforts that are better aligned with voter preferences. But if you combine the two offices into one, you're going to get more total effort. And so there's a trade-off there. There's also going to be an issue with electoral selection, which has to do with how well elections are picking out people for the future. If you combine the guys into one office, you're going to get to learn a lot about that one guy. But you also sacrifice the flexibility of, say, keeping someone who was very good at the schools and getting a new guy for your police. Okay, and those two trade-offs are going to structure our conclusions about how you want to design the offices. So I'm going to jump right into the model, and the setup of the model is pretty simple. Okay, so there's going to be two periods, and in each period, some efforts are going to be taken. There's going to be two dimensions of activity. Effort will be taken on both. Those efforts are going to combine with the competence of the people who are in charge of the task to create outputs. Outputs are valuable to voters and observed by voters. And then at the end of the first period, there are elections, one or two, in which the voter gets to say, I'm going to retain the incumbent, or I'm going to take a challenger. Then in period two, the same thing happens with efforts and outputs, but there's no more election. The game ends at the end of period two. Okay. Now, this slide violates, I guess, one of the rules of writing because we have all this passiveness up here. That's because there's actually two versions of this that we're going to consider. Right? One in which one person makes both efforts, and one in which the efforts are divided between two different agents. So in either case, the output is going to be determined a la the classical career concerns model due to Holmstrom. Okay? So on each task, we have someone in office, and that person has competence, theta. That person also is going to exert some effort, A. And those two things are going to sum together along with an additional term representing luck to determine the output. Everything here is going to be normally distributed. And the uncertainty about the confidence is going to be symmetric. So again, following Holmstrom, the politicians don't know their own competence before they start. Everyone's learning at the same rate. The twist here relative to our previous model thinking about elections in this Holmstrom framework is that in the case where we have bundling, so one person does both tasks, his competences are correlated. So we have the vector of competences is joint normal, and the covariance matrix here has got positive correlation. Okay, now we're going to assume that all of the marginals and the luck distributions all have unit variance. So we've got a one parameter family of information structures. Only the correlation is going to differentiate them. Payoffs are also going to be nice and simple. The voter is going to have linear utility for outputs with weight gamma on the output on dimension 1 and weight 1 minus gamma on the output in dimension 2. That's a second parameter that's going to be important in the comparisons. And finally, we have some payouts. These politicians are going to be office motivated. There is a rent worth R to be handed out to winners of the election in the second period. If the offices are bundled together, that entire rent goes to whoever wins. In addition, the incumbent who's in power in the beginning gets that rent in period 1. And in addition, efforts are costly. We're going to assume a specific functional form for the cost. They're going to be quadratic, which we can talk about what that is buying us later on if people are interested. Now, the very important thing about the bundled payoff here is that the costs are additively separable. Okay, so one thing that you might be waiting for in a discussion of multitask problems comes from the sort of classical Holmstrom-Milgram argument about complementarity in the cost function, right? So if I make someone work really hard on one thing, that makes it have a high marginal cost for them to do something else. That's completely absent here because of this additive separability. So the other thing I have to tell you about is what happens if we have unbundling. And things are exactly the same, but we have to figure out what to do with the total amount of rent. Okay, we're going to keep the total amount of rents in the system fixed between these two institutions. So instead of giving, the same, multiplying the amount of rents and giving it to each guy, we're going to take the same amount of rent we had for bundling and divide it up. Fraction eta of that is going to go to office number 1 that does task number 1, and 1 minus eta times R will go to task number 2. We are going to, later on, optimize over the etas. We're going to do that optimization so that we can compare the bundled institution to the best possible unbundled institution. Okay, so we're going to give unbundling its best shot here. You could think about the possibility that there's some exogenously fixed way you have to divide the rents. That would give you slightly different comparisons. We can talk about that later on. And so now we can ask the questions in a more precise way. I want to know how variation in the correlation between the confidences and how variation in the voters' weighting of task 1 and task 2 affect the optimal institution, bundling versus optimal unbundling. And I want to ask two versions of that question, because I'm going to treat separately the question of which of those is better for first period effort incentives and which is better for second period selection. Okay, and I'm not going to try and combine them into one overall thing because that would come down to really arbitrary assumptions about discounting and other parameters that I don't think are really genuine insights of the model. Nonetheless, I'm going to be able to tell you sometimes what the optimal institution is, because sometimes we're going to have both of those questions have the same answer. Bundling is better for both periods, or unbundling is better for both periods. Sometimes, however, there's going to be a genuine trade-off between the two institutions. So if I want to compare these institutions, I should tell you what equilibrium looks like under each of them. And we'll start with bundling. So you go to the end of this game, and the last step is very simple. Effort is costly, and the second period is the end of the world. So no one's going to choose any positive effort in the final period as a policymaker. So when you go back a step and ask, what does the voter want to do? Well, the voter says, I just want to elect guys based on their competence, right? I benefit from competence, and there's no effort to offset that. So it's really crucial to see how the beliefs about competence are updated. And that's where the correlation makes an appearance as being a really important driver. I've written out here the entire formula in a bit less compressed way than I could have, so you can see the correlation actually doing the following thing. I've got, as a voter, two signals. Okay? So I know the output on task 1 and the output on task 2. First thing I do is a very standard sort of thing to do in this kind of model. I say, well, one thing that went into that output was the amount of effort that the politician took. But I don't actually care about that, because he's not going to take effort tomorrow. All I care about is what the ability was behind that. So I'm going to subtract off my belief about what the effort was going to be. That belief's going to end up being correct in equilibrium, but we're going to not impose that until the end so that we don't do things horribly wrongly. So now I have two unbiased signals. One unbiased observation of competence on task 1, and one unbiased observation of competence on task 2. I'm going to combine them to get my posteriors. When it's time for me to decide what is my posterior mean belief about the competence on task 1, I'm going to take a weighted average. One thing that's going to go into this weighted average is the prior mean of competence on dimension 1, which is 0, so it doesn't appear here. I'm then going to take some weight, which is this 2 minus rho squared times this fraction, times the signal that's directly about competence 1. Right? It's obvious why that's there. That's a noisy observation of the very thing I'm trying to learn about in this row of the updating. But I'm also going to put positive weight with rho times this fraction on the other signal. Right? That's a noisy observation of the other competence, which is valuable to me in this updating because of the correlation between competences. Okay. Now, the next thing I do as a voter is I say, aha, I've got these posterior beliefs, which I didn't tell you, but I should tell you are normally distributed, joint normal with that mean. And I say, OK, I'm going to get expected payoff M1 on dimension 1, which I weight with my preference parameter gamma. And I'm going to get expected payoff M2 on dimension 2 that I weight with my preference parameter 1 minus gamma. And now I say that this expression has got to be greater than or equal to 0 in order for me to reelect you, because 0 is what I get from the challenger, who's a fresh draw from the prior distribution. Okay? And finally, this line right here just rewrites this line using the newly implicitly defined parameter lambda to collapse down the combined effect of the preference parameter gamma and the correlation operating through this updating in the way that I update my observations, S1 minus my conjectured effort and S2 minus my conjectured effort. Okay? That's going to be the mean of my posterior expected utility of keeping the incumbent. And I reelect if that's more than 0. Well, like I said, that posterior expected utility is itself, from the decision-making point of view, a random variable, because it depends on the actual competence and it depends on the luck. And so I need to know its distribution. It's normally distributed. Its mean comes from that linear form for the posterior mean with the expectation of the actual output, which is just the effort, because all the uncertainty is mean 0. It's also got a variance, which, so the variance of that thing is equal to, by ordinary statistical arguments, a weighted average of the marginal variance and the covariance between the 2 dimensions. So I can then use this mean and variance to write down the probability of reelection, which is this guy right here. Capital Phi is the CDF of a normal distribution. Okay? So where are we? The voter has, we've established what the voter is going to do in updating and reelection. Use that to calculate a probability of reelection as a function of the efforts. And so now the politician has got a relatively straightforward problem of choosing efforts to maximize the probability of reelection times the benefits from winning minus the cost of the efforts. And so what I have here are the conditions for equilibrium effort, which are the first order conditions for this program with equilibrium imposed so that the beliefs that the voter conjectures about effort equal to the actual efforts. Okay? Now, I think it's worthwhile to pause for a second and say what the various pieces of these equilibrium conditions actually represent. That's going to be a lot of the intuition for the paper. At one level, it's obvious what they say. They say marginal benefit equals marginal cost. Right? So if you start in equilibrium, the marginal benefit of increasing your effort must be exactly balanced by the marginal cost. What's the marginal benefit? Well, the marginal benefit is you get some extra probability of winning and capturing this rent R. The extra probability you can think was arising in 2 steps. You've got that number, which is the posterior expectation of the utility the voter gets from reelecting you. If you do a little bit more effort, you fool the voter into thinking your ability is probably higher, so you slide that distribution over a bit. The amount you slide it is governed by this parameter lambda. Okay? Now, when you slide the distribution over a little bit, some of the probability mass gets moved from less than 0, in which case you lose, to more than 0, in which case you win. And the amount of probability mass is going to be governed by the height of the density, which is where the phi over sigma comes from. Okay? And so those two components are going to be useful for thinking about the intuitions for all the results that follow. Okay, equilibrium under unbundling is, at least at first, very, very similar. Okay, so again, we're going to say on the one dimension where this incumbent is in charge, the voter says, I know whoever I elect for period 2 is not going to do any effort. So all I care about is my expectation of the ability of the incumbent. Is it more or less than 0? So what is that expectation? It's a number lambda times my observation. Lambda here is the ordinary thing, the ordinary ratio of variances that you know about. It's equal to 1/2 given our unit variances. And so again, you get this probability of reelection by a similar argument. You get the first order conditions. There's one thing here which is new. You have these etas, right? Because remember, we're going to give fraction eta of the reward to the guy in office number 1, and fraction 1 minus eta to the guy in charge of office number 2. So I told you that we were going to choose the optimal version of unbundling. Well, now you can see what quadraticness is doing for us. These efforts are linear functions of the weights by which you divide the reward. The payoffs are linear in the efforts. So if you want to maximize first period welfare, you get a bang-bang solution. If dimension 1 is more important, you give all the rents to the guy in office number 1. If task number 2 is more important, you give all the rents to the guy in office number 2. That, in fact, turns out to be overall the optimal institution, because the choice of how to divide the rents doesn't affect how much you learn about either office because of the additive nature of the production function. Okay, so in fact, it's a genuine optimum taking into account both dimensions to have that bang-bang solution. And we're going to focus on that one in the rest of the talk. Okay, so I promised you a discussion of trade-offs. In order to understand what drives those trade-offs, it's useful first to rewrite the voter's payoff a little bit. Okay, so the primitive way of writing the voter's payoff is in terms of it's a weighted average of the two outcomes. I've gone ahead and I've substituted in the fact that from the ex-ante point of view, that's just the effort because the ability is mean 0. But we can rearrange this into a simple average of two terms. One is total effort, the sum of the efforts, and the other is what we call alignment. Okay? So the alignment term depends on whether or not effort on task 1 is greater than effort on task 2, and also how much we like task 1 relative to task 2. Right? So if task 1 is very, very important, gamma is going to be close to 1. This will be positive, and then we're happy if this is a large positive number. If gamma is close to 0, we really like task 2. That's going to be close to -1, and now we're really happy if this is a large negative number. Okay? And the key to getting the intuition for this model is that once we break it up this way, the choice of bundling versus unbundling, it's got a different answer depending on which one we focus on. Okay? So except for some degenerate cases, total effort is always better when you bundle. But except for the same degenerate cases, alignment is always better when you unbundle. Okay? And so the question then of the optimal institution comes down to, which of those two you want to go for. I can give you a little bit of intuition about why the total effort comparisons and the alignment comparisons go that way. So Ethan will help me if I slip up on this part, because it's the slippery part. In both cases, I pointed out in the first order condition, your marginal benefit from increasing your effort comes from you're going to slide over that distribution of how good you are looking forward at the election stage, and that's going to pull over some amount of probability. So the first of these intuitions comes from thinking about how much you're sliding over that distribution. That is, in some sense, how responsive is that posterior mean to your efforts? not used to microphones, I apologize. Well, the thing that you're trying to manipulate in the bundled case is it's a weighted average of your posterior competence on task 1 and your posterior competence on task 2. Moreover, those things are correlated, and so there's a sense in which the voter is learning more, okay, under bundling. Okay, so think just about dimension number 1. I need to form my posterior belief about dimension number 1. It's going to be a weighted average now of 3 things. It's going to be a weighted average of my direct observation of what happens on dimension 1. It's going to be a weighted average that also includes my prior. And it's going to be a weighted average of what I learn about dimension 1 from dimension 2. Okay? That last part is the part that's not there in the unbundling case. So the question is, where does that weight come from? Well, part of it comes from the prior, right? No, you downweight the prior in the bundled case relative to the unbundled case. And it turns out that this total sum of the lambdas, the total amount that your efforts affect the posterior evaluation of you, is 1 minus, well, it's proportional to at least, 1 minus the weight on the prior and the updating. Okay? So that's part of an intuition for that. This next slide, don't read very closely because there's mistakes. Okay? Let me tell you some true things. I shall start telling you true things by saying, assume that there's no correlation. When there's no correlation, the slide becomes true. Okay? So let's think about what it says in that case. The other thing that's relevant for how much extra probability of winning you get when you take a little bit of extra effort is how much probability mass gets dragged across the threshold of 0 when you do that extra little nudge of effort. And that depends on how the height of the density, which is going to depend in this normally distributed case on the variance of the prior distribution of that posterior thing, right? The posterior evaluation of the candidate. Well, okay, what are those variances? In the unbundled case, that's just the prior variance of the posterior mean. Oh, wow, that's unfortunate. It's just the prior variance of the posterior mean. Okay? In the bundled case, when, again, we've set to make the slide correct correlation equal to 0, it's a weighted average. It's the variance of a weighted average of 2 random variables, both of which have that same variance but are independent. Okay? And that's going to lead to a lower variance in the bundled case. And that's what we call the diversification effect, because it works like diversification in finance. You're averaging 2 independent things, so you get a smaller variance. And the smaller variance means that 1 over the variance is a bigger impact. Okay? Now, as the correlation between the 2 competences increases, this diversification effect goes away. And in fact, where the slide becomes wrong is that once the correlation reaches a certain point, this inequality is reversed. Okay. So in fact, this is not a completely successful intuition for why total effort is greater, since it goes both ways. But it is a thing that happens in the model. So. Okay. Easier to understand a little bit is the alignment comparison. Okay? What the voter really wishes she could do is say, when dimension number 1 is very important, I'm going to reward you when I want to maximize first period effort incentives. I'm going to reward you for what happens on dimension number 1, but not on dimension number 2. If I reward you for what happens on dimension number 2, it distracts you. It now gives you an incentive to do something else. I don't want to do that. I would like to commit to not reward the other dimension. Okay? Unbundling in this model serves as a way of making a credible commitment to only focus on one dimension, which helps get the alignment right. This is the case where if you want to ask later about what the quadratic costs are doing, this is where I'm going to point to, and I can tell you more about that. Okay, so the main result on first period welfare is, well, to this. We've got this mathy thing, but here it is in a picture. Okay? We have a strictly decreasing function, gamma hat, like this, which is always greater than a half, such that it's a function of the correlation, such that bundling is optimal when you're between 1 minus gamma hat, and unbundling is optimal when you're either more than gamma hat or less than 1 minus gamma hat. where again, this is optimal only for first period welfare. And you can see some comparative statics in here as the correlation goes up. So the bundling becomes less likely to be optimal in the sense that it's optimal for a smaller set of gammas. We start thinking about the intuitions for these comparisons. When you have very extreme preference weights, alignment is very, very important. And so the fact that unbundling gets the alignment right is more valuable to you. Also, the diversification effect is going away. And that's taking away from the total effort effect when the preference weights get extreme. When the correlation gets very large, which you'll see, so if we follow a path like this one, the correlation gets large and the distraction effect gets stronger. So you're losing more of misalignment. And again, the total effort effect is eroding as the diversification effect goes away. What's the time now? 6 minutes. So I will say a very small amount about second period optimality. So more math. Here's what's going on. So second period welfare is basically just what is the average weighted by preference parameter for the two tasks competence of the guy I end up with. So who am I going to end up with? Well, from an ex-ante point of view, half the time I end up with the challenger because of the symmetry of the model. And that gives me a payoff of 0 in expectation because he's a fresh draw from the prior distribution. Half the time I end up keeping my incumbent. So what is the expected welfare provided by the incumbent conditional on me having decided to reelect him? It's the weighted average of his competences, given that the weighted average of my beliefs about his competences is more than 0. This is for the bundling case. And then I use the one formula I learned in econometrics about censoring random variables to say that just depends on the standard deviation multiplied by the density. The CDF as 0 also appears in there, but it's just 1/2, so it cancels it's 1/2 over 1/2. Second period welfare is exactly the same thing. So I get, again, a comparison of the variances. Okay. Now, those variances, if you look into them, embody a trade-off about what I get and what I lose from bundling for second period welfare. What I get from bundling is that I'm going to be making a decision about one guy about whom I have lots of information. Okay, so I'm going to be able to make better decisions about this guy than I would if I only got to observe one dimension of his output. On the other hand, my hands are tied. I've got to take or leave him as a unit. And so under bundling, I might find myself in the situation of saying, wow, this guy is great on dimension 1 and terrible on dimension 2. I wish I were unbundled and could keep him on one and not the other, but you can't. And that flexibility is the value of being unbundled. Okay, so again, we get one of these propositions that divides the parameter space into bundling good, unbundling good. And now the picture looks like this. When the correlation is very high, bundling is optimal. Right? When the correlation is very high, first of all, that informational side is very important. And also, you're very unlikely, ex ante, to find yourself wishing you could split the guy into 2, because when he's good on one, he's likely to be good on the other also. When the correlation is smaller, then you're very worried about this flexibility benefit. Something similar happens if you look along a line like this. When the preference weights are very, very extreme, I'm not terribly worried about being caught with a guy who's good on one dimension and bad on the other, because only one of those dimensions is important. And so again, the benefit of flexibility is not very high there. So what we can say about welfare overall, we can combine these two pictures, and we can say, look, sometimes here, for example, the first period and second period welfare comparisons point in the same way, right? If you've got both, if you've got 2 important tasks and lots of correlation, bundle. If you're down here, so you've got low correlation and sort of extreme preference weights, but the curves make that complicated, but basically that, then good, unbundle. Otherwise, your choice of optimal institution is going to depend on things that are just not in the model at all, involving your trade-off between getting good effort right now and getting good selection in the future. And we don't think the model has anything to say about that, so we don't prove a result. So there's lots of things to do with this, we think. One is to get a better handle on the intuition, so that we can explain it slightly more clearly than I think that perhaps went. But there's also, once we do that, lots of applications, okay? So there are some standard ones like, local governments and public agencies or people who have lots of tasks and you decide as an institutional designer how to split them up. And one that we think is also interesting would be federalism, right? So one way of interpreting the model might be to say that there is one task which has to be done for two different groups, right? Same kind of job, but they're geographically located. Now we can think of gamma as the population share. A simple utilitarian objective function is what our welfare comparisons are about. But now there's going to be interesting differences in terms of how the reelection rule works. It's no longer going to be based on this gamma weighted average. Instead, when you bundle, the median voter lives in one of the places, right? And so we think we could adapt this model to talk about that. We have some ideas for extensions, but I am out of time, so I won't tell you about them. Thanks.
Well, so first, thank you very much for the organizers for putting on this excellent conference, and also for having me discuss this very, very nice paper. Let me begin with a discussion just to remind you of what the question is. So imagine that we have a community in which we have two tasks, e.g. Police and schools, or maintaining the roads and the parks. Then the community could create a single position for an official to oversee both tasks, which is going to be called bundling. Or it could create two positions, one for each, which is unbundling. And there's a fixed budget. So this is, we're going to take as a given. We've got a fixed budget to kind of pay for these positions. But we are going to allow that if we create two positions, we can allocate the budget between them in any way that we like. So we're going to assume that. And we're also going to restrict ourselves to selecting these candidates via elections. It's also a restriction, as opposed to paying people or giving them incentive contracts or whatever. And the question is, which system is better for the community? So that's a question that we're studying here. And it's a nice question. It's a clean, nice, sensible question. So that's good with a lot of interest, I think. Okay, so what do they assume? What are the key assumptions of the analysis? The first is that candidates differ in their abilities to do the two tasks, and these abilities may be correlated. So if you're good at overseeing the roads, you may be also good at overseeing the parks. And we're going to assume that the outcomes experienced by the voters are going to depend on the official's ability, how much effort he puts in, and also luck. And we're also going to assume that the citizens have no ex ante sort of knowledge about candidates' abilities to do this job. They're just kind of going to throw them in the job, and then we're going to learn from them by the outcomes, by observing the outcomes they generate actually when they're doing the job. And this is an important assumption, and it's kind of, it's a little strange, but this is what's being assumed. So if I'm the guy in the bundling system, so I'm overseeing the police and the schools, then the marginal cost of effort on my school overseeing is independent of how much effort I'm putting in on overseeing the police. Okay? I'll have more to say about that in a second. And then the final assumption is that there are just two periods. I mean, to go back to this assumption, the reason like that's kind of weird is like if I put in all this effort, you know, worrying about the schools, you might imagine that that's going to make me a little tired when I'm thinking about the parks. You know, that's just okay, and then we have the results. So the systems differ in two ways. First of all, the first period efforts that they induce, and then also in the information about candidates' abilities that they generate. And higher efforts is good because they improve the first period outcomes for the voters. But better information helps voters select better candidates for the second period. Now, the analysis kind of breaks down into, well, what happens with efforts, what happens with information. So with respect to efforts, unbundling is better when one task is much more important than the other. But bundling is better when both tasks are equally important. And that's because bundling generates more total effort. And again, with respect to the effort calculation, higher correlation of abilities favors unbundling. With respect to information, unbundling is better when the correlation between abilities is low, and bundling is better when the correlation is high. And again, greater inequality in the importance of the tasks favors unbundling. So that's a summary of what I see the paper doing. And it is a very, the version I got ends with like cool, no, with a question mark. And I think, yes, I think it is cool. I hope that makes it into the published version, because that would be very cool. But yes, I mean, I like the question. I've already said it's kind of a nice kind of theory question which has kind of application. And what's very impressive about it is that the results are not obvious at all. In fact, I was kind of surprised, because I was expecting bundling not to fare as well as it does. And as you saw with Scott, you know, explaining the intuition, it's all very subtle. So I mean, it's not at all kind of obvious at all. I mean, it's very subtle, and it works out beautifully. You know, as any of you know, if you solve these types of models, you know, they're really usually very painful. And this, I'm assuming they did a ton of work to get it to work out as well as it has done. But it really works out beautifully. And so that's, you know, it's a very elegant, nice paper. And I guess that was, when I was thinking of doing the discussion, I was thinking, well, there's two types of discussions which could be useful here. One would be sort of really trying to explain the intuition, sort of why you get the results in more detail, and sort of saying something very insightful about that. And the other thing to do would be to sort of say, well, you know, let's think of other extensions and cool sort of related questions that we could look at and sort of create more work for the authors. And, you know, as you might imagine, the first type of discussion would be much harder work and would create a very large headache for whoever was doing that. So I hope the other guy's doing that, because I'm not. Because I mean, they really do. I mean, I think the strength of the paper, yeah, the strength of the paper is that you know, they really do a good job in trying to bring out the intuition and so forth. But it is all really subtle. So what I'm going to do, I'm going to focus my comments on kind of big picture things which I think, you know, hopefully create scope for further discussion. These are all things which I think could be done, which are not the same as the paper, so they would be different. They would be different papers, but things which I think are interesting. So the first thing that I want to discuss, and probably this is my most important comment, which may come up even, you know, if I was if I had to criticize this paper, is that the way they model bundling I found a little bit strange because of this assumption about the efforts, that how much effort you're putting in overseeing the roads, doesn't affect the marginal cost of effort when you're devoted to overseeing the parks. Now, so as a result of that, roughly speaking, what happens in the model, this is very roughly speaking, but what you have is the single official in the bundling system, he does twice as much work as an official in the unbundling system, and he's paid twice as much, because we're holding constant the budget, okay? So how do you make sense of that? Well, basically, it's as if, we have one full-time official under bundling. So we hire a guy for the parks and the roads, and he's working, a 40-hour week. And in the morning, he's working on the roads. In the afternoon, he's working on the parks. Okay? That's fine. But the unbundling system, we have two 20-hour-a-week guys. Okay? So that's how to make, I think, make sense of the way that they've done it, which is fine, right? I mean, I think that's one way of doing it. But I think an alternative way of going would be to hold the manpower constant by assuming that the elected official has to hire another public employee to help oversee. And that, so I think that makes sense. You're sort of holding fixed. Okay, we're going to have two full-time guys in the government, and in one system, we're going to have a single head who's in charge of hiring a replacement and monitoring hiring a helper and monitoring the helper and so forth. And then in the unbundled system, we have two separate guys who are directly elected. Now, if you could ask exactly the same question, okay, and that would be a good question to ask. Exactly, you could keep pretty much everything about what they've done, except that now, if you did it this way, there's a bunch of interesting things you would have to get into about what would you assume about the relationship between the official who's elected and the person who he employs, right? And that's like a president who has to pick his Secretary of State or something like that. And what is the nature of the contract between that elected official and the person he hires for the job? And how much discretion does he have in terms of the payment that he can give the person? Does he observe the person's effort? And so forth and so on. Those are all things that I have ideas about, and I think you could totally do this question, but you can see it's a rather different problem, and I think what this notion of bundling would capture is the problem which people have said about bundling is you can't really observe who's responsible for what. The problem is you don't know who messed up because it could have been the other guy, whereas with unbundling, you have a single person to hold accountable. I think if you introduced this way of looking at it, that disadvantage of bundling would be captured. So that was my first comment. I have more things to say about that. Well, maybe we can come up in discussion. Okay, second comment, and this is something which would clearly be a different paper. Yeah, the two-period political agency model, which we've all worked on, it's well loved and so forth and so on, but it is a problem because the second period is so much different from the first, and it creates a sort of artificial thing, and it means that they can't really do like a comprehensive welfare analysis because it's not really clear how to trade off those two periods. Well, how about if we plugged their framework into this Banks and Sunderham's 1998 JET model? This is something for us to discuss. I don't know if it's possible. I don't know how many of you know this paper, but it is a very nice paper. What they assume is infinitely lived citizens and that candidates can serve at most 2 terms, but it's an infinite horizon game. And I don't know. I mean, I don't know whether it would be feasible to solve it under this assumption, but it's not obvious that it isn't. So basically, in this model, what happens is that if you take any one period, you've always got the guy who was in office in the previous period. And then you have to decide whether to replace him with a new guy or to re-elect him. Okay? And what's different about this setup from the Scott and Ethan's paper is that because if you were to reappoint the guy, you know he's in his last period because he's term limited, so he's going to put in 0 effort, which is exactly the same as in Ethan and Scott's model. But if you put in the new guy's going to be in his first term, and he wants to stay for a second term, so he has positive effort incentives. So you might say, well, you always put in the new guy, right? But no, that's not the case, because the old guy may have a sufficiently high type that his, even though he's not trying that hard, his ability is going to make him better than the new draw. So that's how this model works. And it's not obvious to me that you couldn't ask Scott and Ethan's question in this model, which would also be very cool, I think. OK. The final, not the final comment, but the final suggestion for other things, other sort of related models to look at, is that the nature of the agency problem in this paper is that candidates may not put in enough effort. And that's fine, there's nothing wrong with that. But another concern is that candidates have different policy preferences than the citizens. For example, you could have green candidates who don't believe in using salt on the roads or weed killer in the parks. And because you don't actually get to observe type when you're electing, they may sneak in, okay? And then in that case, it would seem that bundling may be a lot more risky than unbundling, because once you get a head guy in who has these weird preferences, he's really going to mess up, whereas if you have the separate draws, that's going to be better. And that's another kind of a trade-off that could be explored in this nice framework that they've created. The final comment, and I hope that John Hatfield was going to be here, well, but I guess he isn't. But I partly put it in because he was here, and I thought this would be a good thing to discuss, is that I read, as a good discussant, I read some of the things that they cited because I wanted to see where the paper fit in the literature. And this paper by Hatfield and Miguel does seem very related, and I thought it was, and I took a look at it. It's not published. I don't know why it's not published, but there's always a risk when you're discussing like an unpublished paper, from years ago that, oh yeah, it's well known that that's completely wrong or something like that. I don't know whether, but it seemed a very nice paper to me, and it seemed related. But it's a simpler model. In some sense, it's not as nice a model, but I thought that it would be a useful model to relate to more. It's mentioned in the paper, but I think there could have been a more fruitful discussion of it, because in some sense it's easier to understand. It's nowhere near as subtle as the Scott and Ethan's paper. So they have nothing to fear from it. It would just be useful for the reader to discuss it. So what this model has is it just has discrete policy outcomes 0, 1, but again, 2 tasks. And they start off by saying, well, what would happen if the candidates have identical abilities, and then the voter could commit to re-election, like in the standard kind of Farragon model. The voter can commit to a sort of re-election contract. And then they show that unbundling is superior in that environment since it generates higher effort. When candidates have different abilities and policy outcomes depend only on ability and luck, that's the next thing they do. They say, OK, let's put in ability and luck, but let's take out effort. Then they show that bundling is superior because it generates more information. And then they kind of put them together, and they say, all right, well, we got the whole setup, which is what these guys have. Then they show that the optimal system depends on whether effort is more important than information. So the impression that they give is that unbundling is better for effort and bundling is better for information. And the message coming from this paper is much more nuanced. So I was trying to understand why. Well, it's a different model. So basically, what Hatfield and his co-author are assuming are that abilities are perfectly correlated across tasks. So rho is equal to 1. And that both tasks are equally important to the voter. So the gamma is equal to 0.5. And then, but under those conditions, actually, this Scott and Ethan's paper suggests bundling should be better than unbundling in both dimensions. But one difference between the approaches is that the Hatfield paper assumes that the rewards from office are independent of the system. And I don't like that assumption because it means that basically more resources are being used in the unbundled system. And therefore, you're not comparing, like with like. But nonetheless, like if you could just, explain, how your paper relates to this paper in more detail, I think that would be good. All right, that's what I had to say.
All right, so the previous discussant and I did not coordinate our discussions, so you'll find that this is another talk where I give you more work to do. Hope that's okay. So let's start again just by going over the logic of the model. They talk about a two-period model where we can either have a unitary executive or a divided executive branch, what they call bundling versus unbundling. And then they separately look at the trade-offs in the first period versus the trade-offs in the second period. So in period 1, we just have an effort margin. There's no selection margin because we're drawing candidates from the same pool, regardless of whether it's the bundled or unbundled system. So what are the incentives for effort in the first period? Well, if we have a unitary executive, as they described, it turns out that we have a higher total effort, which is a good thing for bundling, but there might be misallocation of effort. You might put effort into the unimportant task in order to signal your competency on the good task, which is a waste. And so if we think about when this misallocation is a problem, when does this bite? Well, misallocation is going to be bad when the correlation between competences is high, because that's when the signal is meaningful. If there's no correlation, then my performance on task 2 doesn't say anything about my quality on task 1, and so there's no need to misallocate effort. Moreover, misallocation of effort is going to be more of a problem when the decisions are very asymmetric. If the decisions are equally important, then you should be working on both tasks, and so there's no meaning towards misallocation. You should be allocating effort on both dimensions. And so we see that a bundling, a unitary executive branch, is going to be relatively worse when the correlation is high. You see that we're moving from bundling to unbundling as we move right. And bundling is going to be relatively bad when the importance gamma is extreme, when the decisions are very asymmetric. And that's what we see when we move from the middle to the outside there. So those are the incentives on the effort margin for the first period. And now let's look at the second period, where it's the last period of the game, so there's no more effort. We only have selection. If we have a unitary rather than a divided executive branch, then we end up getting a better signal of the competences if they happen to be correlated, because effectively we get 2 signals rather than 1. So the more correlated are the competence levels, the better a signal we get of is this unitary executive high quality or low quality. So that's going to push us towards bundling when the competences are correlated. And then the other issue is that if the competences happen to differ, if the unitary executive happens to be very good on task A and very bad on task B, there's no way to keep him on for task A and kick him out for task B. So that's the flexibility dimension that Scott talked about. A benefit of having unbundled executive branch is that you can kick out on one dimension and keep on the other. And so when we think about this flexibility issue, it's going to be less important when the correlation is high, because it's very unlikely that you're good on one task and bad on another task. If you're good on one, you're probably also good on the other. And the flexibility is also relatively unimportant when only one task matters. If I only care about task A, then it's not a problem that I have to keep you on for both tasks or kick you off for both tasks. That only matters when I care about both tasks. So that's the basic logic of their model. And then we put them together to get this picture. And the talk, I think, was very clear. The talk in the paper were very clear about these trade-offs. I don't think that they highlighted the contradiction between them. There's some focus in the talk on maybe we're in this case or that case where there's no trade-off, otherwise there is a trade-off, and then we should think, is period 1 more important or is period 2 more important? What they haven't highlighted is that these incentives, kind of ignoring that in their particular model there happen to be cases where there aren't trade-offs, these comparative statics push in exactly opposite directions for period 1 versus period 2. And so in order to actually think about when should we want bundling, when should we want unbundling, given these, given some set of parameters, let's say I know the correlation is really high, does that push me towards bundling or does that push me towards unbundling? We really need to know, does period 1 or period 2 matter? And I think they gloss over this a little too quickly in the paper just by saying it could go either way. So here's precisely what they say. We think of the second period as, in a stylized way, representing the future. As such, it's unclear how much weight the voter should put on the first period versus the second. Depending on the voter's patience and the expected length of the future, any weight between 0 and infinity might be appropriate. So I think this is, I understand the logic here. Let's focus on the two factors they discuss, the voter's patience and the expected length of the future. I'm not sure how to interpret when are we in a world where the future is long versus a world where the future is short, especially because you'll notice that all of this importance of the second period is only on the voter's side, not on the politician's side. In the model, there actually is a parameter that tells us how important is the future for the politician. It ends up being determined by the ratio R over K, where R is the benefit to the politician of getting reelected, and K is a cost parameter of effort in the first period. And so if we think about making the second period longer or the second period more important, in this implicit comparative static, we have to be fixing the importance to the politician. So I'll come back to that one. The one that I think is maybe more clear is the voter's patience level. We could certainly imagine varying the voter's patience while keeping the importance to the politician constant. And so let's focus on that issue. What does this model really say about the patience of the voter, presumably compared to the patience of the politician? Well, it doesn't precisely say anything in terms of giving formal results about this, but I think the model does give us some strong intuitions. And this is one of the things I really like about the paper, is that the intuitions for the trade-offs are very intuitive, very clear, very well explained. So here's the way I would intuitively think about this problem, given the results in the paper, given the descriptions in the paper. You could kind of say, you could very reasonably say we live in a world where voters are patient and politicians are impatient. So this is a world where the politicians only care about winning the next election, whereas voters are forward-looking and they have a stronger interest in society as a whole. So the logic of the paper perhaps suggests that when the voters are relatively patient and the politicians are relatively impatient, that pushes us towards the comparative statics of period 2, which, recall, was we bundle when there's a high correlation or asymmetric decisions. Now, you could completely reasonably tell the opposite story, that voters are myopic, voters are very impatient, whereas politicians are calculating and rational. And so the politicians are patient, the voters are impatient. And again, I think the logic of the model suggests that this pushes us towards a world where we have the period 1 comparative statics, where you bundle with a low competence correlation and symmetric decisions. And so I like that the paper gives us intuitions about this. I wish the paper had given us results about this. Now, moving to this other issue about thinking about the expected length of the future, the previous discussant also mentioned this issue. I think the natural way to think about that kind of issue would be moving towards a more fully dynamic model, having many periods rather than just 2 periods. So how do we do this? Actually, he proposed looking at a model with term limits, where you're either, after you're reelected once, then you're out. And I think, as you said, you probably could solve that model with the techniques in the paper. I might be wrong about that. I think you should be able to. It would probably give you very similar results. Unfortunately, I'm not sure what it would tell you about the length of the future, the expected kind of how much weight to put on period 1 versus period 2. So let's think about a different kind of model that would presumably be much harder to solve, but maybe we could get some intuition for what the results could be from the arguments of the paper. So let's have a world without term limits, and so therefore we'll get effort and selection in each period. These dynamics never go away. So as I said, following the logic of the paper, just following the intuitions, I think now I might know what happens in this model without being able to solve it. Perhaps if we just look at the comparative static of how patient are the politicians relative to the voters, as the politicians get more patient, effort becomes more important. The politicians are working harder to keep their jobs, and so the world is a little more like the period 1 world. If the voters are relatively patient, then selection becomes more important. The voters are willing to kick out even candidates who are very good because they're waiting for a candidate who's great. So they'll have a very high threshold for keeping someone on. Selection becomes more important. Perhaps this pushes us towards a world where the period 2 comparative statics are more important. They become more relevant. So as I said, the paper gives us very nice intuitions for thinking about these issues, certainly intuitions I didn't have before reading the paper. What I would be interested in seeing is it possible to formalize these ideas? Or am I being misled by them? Maybe the selection dynamics are just completely different in this many-period world than they would be in a 2-period world. And that's something I'm not sure about. Changing gears here a little, here's another suggestion for some more work for the authors. Here's a comparative static they don't consider, but I think they could consider much more easily than any of the previous ones I've been talking about. And I think I know what the answer would be, again, because the intuition of their model seems so clear. So in the current model, the outcome is going to be effort plus competence plus noise, where the noise and the competence are both normal 0, 1 random variables. And there's no reason why these need to have the same variance. You could very easily write a model where we had a more precise epsilon, so a smaller variance on the epsilon, keeping the competence constant. I would be shocked if you were unable to solve that model, given that you've solved the current model. And so what result might we get from this? Well, as you reduce the variance of epsilon, we now have a more precise signal of someone's competence level. And how does that play into the intuition of the trade-offs? I think that the only way it would play in is that previously, one benefit of bundling was that it gave us more precise signals because we got 2 draws rather than 1 draw for how good is this politician. And so as we now have a more precise signal for free, presumably that would be a substitute for these having 2 signals. And so one of the benefits of bundling would go away. It would be less important to get the second signal. And so my guess is that if we were to increase this precision in terms of reducing the variance of epsilon, that would push us towards unbundling. Again, I don't know that this result is true, but I think that the logic of the paper suggests that it might be so. So summing up the discussion, the paper talks about the trade-offs of bundling versus unbundling. Unfortunately, the period 1 results are completely opposed to the period 2 results. I think the authors might disagree with that characterization, but that's the way I read it. And so I feel like I don't get strong intuitions about when we should bundle or when we shouldn't bundle. However, because the trade-offs are so clear, I think they might be able to push further and make more precise what do we mean by the importance of period 1 versus period 2, find a way of putting that into the model, maybe making things more dynamic, maybe just looking at some additional comparative statics that they haven't looked at yet. And of course, the question in all of these is, I think I know what the answers would be given the intuitions of the paper, but maybe I'm wrong. And that's what I would want to, that's what I would be interested in seeing from, maybe not this paper, maybe the next paper.
Thank you to both discussants. Those comments were very thought-provoking and are going to help us a lot, I'm sure. I can say a little bit in response to some of them. So first on the separability of the cost function. So yeah, obviously it's a very strong assumption. One reason that we made it is we think that we already know a lot about the way that spillover works. So it's a sort of classic Holmstrom-Milgram kind of story, right? Where I give you incentives that make you work really hard on one job. It makes it harder to incentivize you on the other job because now you're working really hard. Your marginal cost has gone up. And yeah, we could certainly add that. We wanted to, at least in our first attempt to understand this model, ignore that force to focus on the linkage between tests that comes from the correlation, which is why we did that. In terms of different ways of modeling bundling, yeah, so one question when you start thinking about moving away from this model towards discussions of things that Chris and Jake think about in political science is let's not go too far. What exactly is your vision of what presidents do all day in this model, where they seem to actually be taking effort on the Army and taking effort on like the IRS, instead of having people that they don't even know in the IRS doing things that they don't want to be done, which apparently is the story of the week. Yeah, that's definitely a thing to push on. And so that might be a sense in which the model is not a perfect fit for what I guess is the real world. I do think that one interesting thing comes out here, even relative to your comparison of the full-time guy versus the 2 half-time guys, right? So certainly it's true that one thing that you might do in the model is you might unbundle in such a way that you divide the rents equally between 2 offices, and you will in fact get 2 guys doing roughly half the effort as if they were half-time guys. But you never want to do that. What you end up doing is you end up creating one unbundled office that has 1 job, and you give him all the incentives, right? So you have all the incentive power going either to a guy with 1 job or to a guy with 2 jobs. And so the question we're asking then is it's still the case that even though you basically, instead of having 2 half-time workers, you have a full-time worker and a no-time worker, there's still an interesting trade-off between the two institutions. So different policy preferences, I agree, is important. Do you have any thoughts on how things would change? I don't on that one. I'm sure they'd be different. So I'm going to come back to the infinite horizon discussion at the end, since that was the intersection of the comments, and instead talk a little bit about the interpretation of, do our results say that there's a very strong conflict between what period 1 says to do and what period 2 says to do? And I actually think that that's right. I think we draw that picture to show we can't prove a theorem that says that. But yeah, the force of it is, in particular, when you start to think about what do I believe is going to be true once I get away from my quadratic cost function and my normal distributions. The force of it is correlation makes one of them good for one dimension and bad for the other dimension. That's exactly right, I think. In terms of comparative statics of the signal precision and the marginal distribution, yeah, I think that that's something that we should probably do. I mean, certainly it's the easiest of all the suggestions, and so we're sure to do it. So the other thing that came up in different ways in both discussant comments was how to think about the future, right? And this is something where, as Alex said, we kind of punt and we say there's a future and there's a present, and I can tell you about both of them. I'm not going to knit them together very carefully. And a way to knit them together more carefully would obviously be to look at an infinite horizon model. My guess of what would happen in the Banks-Sundaram style model is not a lot would change. There would be some differences because now it's no longer the case that you want to re-elect the guy if your posterior is more than 0. You want to re-elect the guy if your posterior is more than whatever is the implicit definition of the equilibrium effort of first period guys. You want to re-elect it if you're more than that. There's a counterfactual. There's a thing which is going to make the real world people in the back row unhappy with that model, which is the incumbent's going to lose more than half the time with these normal distributions, right? Because the distribution of the posteriors about him is symmetric. And I'm saying you can't set the re-election threshold at 0. You've got to be more intense than that. So incumbents are going to lose a lot.
You could add like a benefit of...
You could add learning by doing or something like that to get away from that, yeah.
It's also going to be the case in that model that all those first period comparative statics now affect the re-election rule. Right? So anything that increases first period effort.
It's not clear you couldn't handle that, though. You can implicitly determine what they are. Yeah, might be interesting. The model without term limits, I have much less hope of being able to solve. Ethan and I have both, at various points in our lives, spent many, I think, safe to say, fruitless months thinking about infinite horizon versions of this. And it's very complicated because one thing that happens is if you allow for a very long time horizon, you get a guy, he wins because the voters said he's better than average. Then he won again because he's even more better than average. And so there's sort of a ratcheting up of the beliefs about the ability of guys as they stay in office for a long time. And if you look at the incentives for effort, without thinking of the future, you see that they decline as he gets ahead, right? Because he has to exceed the threshold. And so knitting together the model to incorporate that fact as well as the selection turns out to be extremely difficult. And the reason the literature is so obsessed with these not fully satisfactory two-period models is because I think the only real progress on that is some recent papers by John Duggan which say there exists a Markov sequential equilibrium. And so we feel stuck. But thanks again, those comments were wonderful. Will Howell.
Can you say a bit about, you've got the same voter in 2 periods, regardless of whether or not it's bundled or not, right? So the natural thing, thinking about unbundling is having separate elections and different electorates, and they might have different preferences over. So this goes into the world, more naturally goes into the world where you think about differences in the preferences of a policy between the voter and the elected individual. But
well, so
how does that map in?
Let me see if I understand. So in our model, there is one electorate, right? Think of it, it's the electorate of the city of Chicago, who has got to elect, since I don't live in the real world, it has to elect a commissar of police and a commissar of schools for the city of Chicago. That's exactly what our model's about. Now, in many cases, what you see is not that exact overlap of jurisdictions, right? You see a much more complicated nesting where I elect one guy who's in charge of the police in my city and another guy who's in charge of something in my county. Okay. I don't have a strong sense of how that's going to play into the model.
Who come out to vote for the world in which the
Oh, so you want this, you want these guys' story where the electorate changes endogenously.
But in this kind of a model, I mean, there's this kind of common values, right? It's just everything's increasing in effort and everything's increasing in ability. There isn't going to be a kind of voter who
Which is
just
why I
places
said
another
it's
kind
not
of
more
voter.
natural a world in which you have differences in preferences.
I just think it's the wrong kind of model to think about that kind of problem.
But that might make it the wrong kind of model to think about unbundling, because that's a very relevant
It's
aspect.
the wrong kind of model to think about unbundling that's about ideology.
Lars.
So I haven't thought too much about multidimensional normal learning models, but there's an assumption you make that I can't quite decide if I like it or not, because the epsilons are correlated.
Yes.
So you might imagine, for example, that the thetas are the permanent components, but the epsilons might be possibly correlated as well, so like per-period shocks.
Yes.
And it seems like that might change everything radically. Like, so imagine that all the thetas are independently distributed. There's no correlation.
Yeah.
But the thetas are positively correlated. Now, before, if I had a good outcome on task 2, you updated my theta on task 1. Now, if I have a good outcome on task 2, you decrease your expectation on task 1 because there's a common shock, right? So if one's really bad and one's really good, then you actually want to put zero effort in one thing and a high effort in the other if you want to convince the person you're good at the other one.
Yeah, the intuition, I think, sounds sound. Now we've worked on this, but not to the point where I can tell you the answer, because the thing that we worked on, perhaps foolishly, was we said, what if we took this model and also let the epsilons be correlated? And the answer is things change, and one of the things that changes is we don't know the answer anymore, because it's harder. I think we should go back and do exactly your model, which is you shut down the one that we have and add the other correlation. We might be able to actually make progress.
And in terms of the economics or the politics or whatever, the assumption, the preferences, what does it mean? I mean, did you think more about, is it a reasonable thing to believe that these shocks are permanent and there's no transitory positive correlations? Or I just haven't thought about what that would mean in this context. Somehow that you think that you're new in the job, some people learn very quickly, some people don't learn very quickly on either task. That's the kind of shock that we're worried about.
Yeah, the story that we have in mind here is there are these two different kinds of jobs, and people, and that a talent is a multidimensional beast, right? And so some people are permanently good at doing one job, and people are permanently good at doing the other job. And you want to know, did you get a guy who's just good at one or good at both? And so we're ignoring all these issues. I think one thing that was pointed at in your comment is there might be different abilities to learn, not in the sense of learn about the politician, but to learn how to do the job. And we don't have that. I think that would fit very awkwardly with the two-period model.
We tend to think about the epsilons as shocks from the world, right? So
Yeah.
when we talk about this, what we talk about is like, well, maybe there's some jobs that you bundle together that interact. You might want to ask the question, do you want to bundle together jobs that interact with the world in the same way or that interact with the world sort of fundamentally different, which would be about correlation to the epsilons as well. That's sort of how we got into trying to,
Yeah.
but we never did it by shutting down the correlation of data.
We should do that.
possible for us.
John.
I'm super excited about this paper and what will come of it, and I think it's a really good idea. But it's obviously an enormous issue. What is the benefit of bundling and unbundling? And Barry and Gerson have a different line of argument about whatever that is about. Susceptibility to special interests or something to this effect, if I'm not mistaken. Will's talking about ideology of voters that are going to key on different issues, and I'm wondering what is the rationale for focusing on these specific slices of the issue among the many others, besides what these guys talked about. I mean, there's dozens of things that could affect the relative value, and I'm not saying you should tackle them all in one paper. Why are these the things to tackle first? With your
Leave that to
your ability
Ethan.
to do
I just.
The honest answer is this is the kind of stuff we work on.
Yeah.
the same reason that you work on cheap talk models of the bureaucracy. It's what you do.
Right on, just making sure. You might say, well, because we looked at all the other things and they were just dumb. And then I would think, well, I
looked
should.
at Chris and Jake's paper and it was dumb.
To be
But
fair,
now I think maybe I can write a paper on unbundling because there's all these other things out there.
let's be very clear. Ethan looked at Chris and Jake's paper.
talking
I thought
about
unbundling was just the name of a new way to do political agency models.
No, I don't think we have like a deeply principled answer. We work inside this class of models and it seemed like an interesting question.
There is, by the way, a big aspect of cheap talk in this, which is if you're all bundled together, your Secretary of State sends a message about a policy shock to your Secretary of War, and they're all in the same room. If it's if you have bundled, decision making, and if there's some, it's a little bit related to your dimensional, dimension by dimension competence shocks, but they can send messages to each other a little bit easier if they're all part of a bundled institution.
I think that if I was going to try and take our modeling tools and try and get closer to what I understand of this literature, I would want to say that the real competence that is at issue for a top-level executive is some sort of competence in managing the organization, right? So he has to actually find people, delegate, and oversee them. And I think that it would be interesting to write down a model in which that was something you could actually talk about directly. This is not that model. This is a model where you're taking efforts more directly that lead into policy.
Since you have a separable cost function, if you do you're thinking about one guy, is doing each policy, but if you think about them as having agents, there are a lot of implications for the competence or the quality of institutions to manage your underlings, and the fact that you have the separable cost function. It's like you set up OIRA to review things your underlings the actions your underlings are taking. Once that is set up, then it's not too costly to have it work for,
Yeah. So one extension that we have worked on.
But there's a lot of complementarity in that cost function of effort, whereas you guys don't have.
That's right. So one thing that we have worked on, and I don't remember the answer, but it's written down in Ethan's office, is we have studied spillovers between task and the effort. So that what if some of my efforts on doing task 1 well spill over and make task 2 go better also? Yeah. And I think that would help to get at this. That would help to get at this.
So you said you're ignoring the issues of delegation and stuff, but there kind of is. I mean, you could choose to see it that way, but there is some of that aspect of how good are you at delegating and managing your span of control that's packed into the cost function.
Jake.
You guys, you focused on this question of, the bundling question, and at least in con law that we have this separation of powers, or separation of government functions as well, which I think is just going to code as something like team production, as you have different institutions or actors who are both offering inputs to produce a joint policy. And you could do that, of course, in a bundled world or an unbundled world as well. And the question is how to take that class of idea or model and put it together with this one, if that's possible at all. I suspect it's not, but can you help me think it through?
That's exactly the model with spillovers and effort.
Yeah, that was sort of why I asked.
No, that is what we're working on. So that's exactly why we started working on the right. So the idea is that either the two stories people tell is either coordination, right, or some sort of externality stories, and they're closely related in this setting. And so our thought was, so we could build, right, you could build directly a team production problem into this model by just having task 1 effort also spill over to task 2, and task 2 effort spill over to task 1, and I think capture the spirit of that inside this model.
What's going to happen? Do we know? Sorry.
What's going to happen is that we're going to write an answer to that at the end of the summer.
I'm very excited.
No, we've worked on it together. We're not there yet.
So we've made jokes about the connections between theory and data, but in all seriousness, having worked, so there's lots of data out there on just say like governments, and we know how many officers are elected or appointed, for many, many thousands of governments, state governments, local governments. We have a lot of good data, and over time we could say, and we have a lot of outcomes and performance measures of these governments as well. So based on, your model, are there any sort of obvious things to take to the data, or like a first sort of thing you might look for in the data as that the model would direct us to?
I mean, that depends on how you think institutions are chosen in the first place. If they're all chosen to be welfare maximizing,
Yeah.
The answer can be no. That'd be fine.
I
I'm
think
just
they're
curious.
not.
No, I think that the one that sort of most
No, I mean, imagine you could get an empirical proxy for variation in the precision of the signal, because I assume you empirical guys can observe how often things are covered by the media and across different jobs, right? That's the kind of thing that you can imagine measuring. Sean's question, though, is a good one, because what the model's going to give you pretty directly is if you sort of fix the institutions. Say everyone's got a bundle, right? Then the model's going to very directly give you a prediction of how actual performance is going to vary with a parameter like the precision of the information. Okay? It'll do the same thing for unbundling. But when it comes to, so if you want to condition on the ones who are bundling, the model's going to give you a prediction. If you want to do empirical work on comparing bundled and unbundled, you are going to want to worry about why you've unbundled.
Oh yeah, but leave that as an empirical problem.
Okay, that's your problem.
It's not an empirical problem. But okay.
Suppose you had some of these exogenous variations. I'm just saying for the sake of argument, suppose that were.
I mean, the thing is, our
I'm trying to
model.
give anything. Don't say I can't give you a theoretical prediction because I don't have an identification.
No. That's not what I mean. That's not what I mean. That's not what I mean. What I mean is the model is agnostic as to whether or not you have an identification problem. Because the one way to construe the model is it is a descriptive model of what you will see in the institutions, and then we have done a normative analysis, which tells you need one kind of identification strategy. Another way to construe the model is this model is, in some sort of very Supercosian sort of way, a model of what the institution is. Okay, that needs a different identification strategy. And the model itself is not going to tell you which of those two construals to give to the model. And that's where I'm pointing to the additional concern for the empiricist.
So if I get an identification strategy, then maybe you'll come up with a question. I'm just kidding.
If you really want to write a paper with this, we can work something out, I'm sure.
No. That's precision of the signal seems good. If there was somebody getting like data on newspapers or something.
Yeah.
All right. Okay.
Thank you.